For the second part of the test, you get to use your graphing calculator. Lots of things are going to be similar to what you did in the first part. You're going to have to find inverses, graph and find some things, deal with the composition of functions. You'll need to prove some inverses, prove that things are odd or even, and then you'll have some questions about other things and also finding the line of best fit between some data and then answering some questions about that. So, in looking at some more examples of the things that you will see on the second part of the test, starting here with this slide, proving that things are even or odd. Remember that you have to substitute an f negative x in and see what happens. And so when you substitute a negative x into this, you would get 2 times the negative x squared minus 5. And when you take the negative and square it, that becomes positive, so it's 2x squared minus 5. This now is the same as that, and so since it is the same as that, it would be considered an even function. And also it's an even function because no matter where you have a coordinate, let's say you have this one 3 comma 2, you would also have to have a coordinate on this side of a negative 3 comma 2. Now if you try to turn this around and prove that it is odd, you would still substitute a negative x in, and in that case if f of x is, let's start this over. If you substitute a negative x into the equation, you would get 2 times a negative x to the second minus 5, and then you would have 2x squared minus 5, which we've already shown that it is even, so therefore it would not be odd. If it were odd, then you would have to have a negative 2x squared plus 5. That would make it odd, but that is not possible when you substitute a negative x into that particular function. So in this case, this one is even. All right, then, proving that things are inverses of each other. You have f of x over 3 minus 2 and 3x plus 2/3. To prove their inverses, you would either take that or this, which is the composition of the two functions. So you're either going to take this and bring it over here and put it into x, or you're going to take this and bring it over here and substitute it in for that x. Doesn't matter which way you do that. Either way, if you get plain x when you're all done, they are inverses. So substituting in, we're going to do the black one. So we are going to have 3x plus 2/3 over 3 minus 2. And so now 3x over 3 is x. 2/3 divided by 3 would be plus 2/9 minus 2. And that is not going to equal x. It's going to be in negative 1 7/9. And so therefore, they are not inverses of each other because we have this negative 1 7/9 attached to the end of it. And that's proving that they're not inverses. Next, we'll get back into evaluating some functions. You could try to graph these things or make a table of them by using your calculator and going into the table your y equals and entering any one of those equations, like say x squared plus 4, and enter. And then if you wanted to figure something out with it, you can go into table set if you have this type of calculator and turn that into ask. And then if you wanted to go auto and it just figured everything out for you by changing that number to say 0, table change is 1, and then you go to auto, and then if you hit table it will give you all the values, and those are these right here, this 4, 5, 8, 13, 20, 29. That's what you get when you substitute any value in to the middle function. Or you can just do it without using your graphing calculator and putting it into the functional part by just substituting a negative 3 into the equation to get 13. Another example here, and we're going to change this operation because I think we did that operation before. Let's turn this into divided by. So f of 2 is going to be 2 times 2 minus 3, which is 1. And h of 2 is going to be 2 plus 2 minus 5, which is a negative 1. And then 1 divided by a negative 1 is a negative 1. And finally, G composition, f of 3. Remember that you have to do this function first. And so f of 3 is equal to 2 times 3 minus 3. And 6 minus 3 is 3. And then you take that number and substitute it into the G function. So 3 squared plus 4, and that will be 13. Now you may also get something like this where it's just f composition g of x. And so then here we have to take the g function and substitute it into the f function. So we would get 2 times and then x squared plus 4 minus 3. And simplifying that, you would distribute the 2 to get 2x squared plus 8 minus 3. So 2x squared plus 5. Finally, finding the inverse of g, switching x and y. So you would get y equals x squared plus 4. Or now just solving for x. Subtract 4 to get y minus 4 equals x squared. Take the square root of both sides. And x would equal plus and minus the square root of y minus 4. And so then the inverse of that would be plus and minus the square root of x minus 4. Finally, looking at some of these again, just to refresh, as you will have some of these on the test as well. The parent function for this is x. The parent function for this one is x squared. The parent for that is the absolute value of x. There are other parents like 1 over x, 1 over x squared. There's the ceiling function of that. There's x cubed, the square root of x, and the cubed root of x. This 1 over x looks like this. 1 over x squared looks like that. That one is one of those things where there's a circle and a closed one. It would be here's that, and that's open. X cubed goes like that. The square root of x starts at 0, 0 and goes like so. And the cubed root of x does one of those things, going through 0, 0. So you better remember all of those and understand which ones are even, which ones are odd, and which ones are neither. Domain for a line is all reals. Range is the same. And this one would be neither, because you can't fold it and you can't spin it on the origin. The x squared plus 4, it's all reals. All greater than or equal to 4 because it's shifted up 4. And this one would be even. And our last one, domain is all reals. Range is all greater than or equal to a negative 5. And the domain, or even, odd, or neither, would be neither because it's shifted to the left 2 and down 5. And so the V is going like that, which you can't fold it or spin it either. And we will skip these two because I don't think there's any on that part. And so now again, another one example of trying to prove that things are inverses of each other. You would have to either take F composition G of X or G composition F of X. Which one do you want to do? That is completely up to you. We are going to do this one for today. That means we have to substitute that function into that one. So we would have 3 halves times 2/3 x minus 5 plus 5 halves. Because that whole thing has to be replaced there. And so distributing the 3 halves to both things, 3 halves times 2/3 is 1, so we have x. And that would be minus 15 over 2 plus 5 over 2. This does not turn into 0, so you're going to have x minus 10 over 2, which is x minus 5. And since there is an attachment to the x, it is not, or they are not inverses. And one more time, proving even, odd, and neither. If you substitute a negative x into this, negative x squared plus 8 would be x squared plus 8, and that is the same as that, so yes, they are even. Taking the second one and proving if it is odd or even, let's substitute a negative x in first, and you would get a negative x to the third plus 2 times a negative x minus 5. And simplifying this, it would be a negative x cubed minus 2x minus 5. Now, is this the same as that? No. So, not even. If you take the opposite of that thing, you would get a negative x cubed, which is the same as that, a negative 2x, which is the same as that, and a positive 5, which unfortunately is not the same as that, so therefore it is not odd either. Had that been the opposite, then yes, they would have been odd. And that is pretty much everything as far as doing those types of things. Now you will also recall that I told you you're going to have one where you have to find the line of best fit things. So there you're going to have to go into your calculator. If you have a TI, you would go into Edit, push Enter, and enter your data. If you have a Casio, you would hit the menu button, find the stat thing, go in and enter your data. And remember, if you want to delete things in here, with this one, you would go up and hit the clear button. On a Casio, you have to hit F6 until you find the one that says DEL-A, and then hit that, and you will be able to erase your things. Once you get your data into it, on a Casio, you can just hit the graph button and hit GPH1, and it should draw this fine looking figure that we have right here for you. The line won't be there, but all the dots will. On a TI, you have to make sure you hit second and stat plot. Make sure that is turned on, and if it is, then hit the graph button. And that will show you the scatter plot. And on a TI, you have to make sure that you zoom number 9, which is zoom to the stats that you have, and then it will show you all the different information. After that, then you need to calculate the line of best fit. On a TI, you go into Stat, shift over to Calc, and go down to number 4, Len Reg, hit Enter, and there you have your information. 0.475 is the slope, 3 is the y-intercept, and the correlation coefficient is 0.801, which means it's a strong positive correlation. Then on a Casio, if you want to do that down at the bottom of your screen, you're going to hit the Calc button and then choose x and then ax plus b, and you will get the same thing. Then if you want to draw that line in, you can hit a draw on a Casio for both of them, though you have to transfer it over and get it into the part where you need to have, oh, that was kind of freaky. All right, let's see. You have to transfer it over into this y equals part. And I've already done that, so it should be okay. But in order to get this in here, first let me clear this one out. And then you would want to, after you get up into here, you have to go to vars, down to number 5, over to EQ, and then number 1, and hit enter, and it would be there. And now I have 2 of them because now there's down to 1. Then once you have it, you hit graph, and now it's there. And then you can use that then to figure out some more information about it and do some predicting of other values. On a Casio, when you get this thing, you have to hit copy. It's going to jump over to the y equals part of your calculator. You hit enter. Then you have to go into the menu of your calculator and go over to graph and find it on your graph section. And when you get to that, in this screen, you have to make sure that the equal sign is highlighted, and to do that you have to select it by pushing, I think it's F1, and then it will draw it. Casio, though, will not draw both things at the same time, so you will lose the dots, but you've already figured out what you need to using the coordinates. And then you may have to answer another question. Remember, on a Casio you can do the YCal or the XCal. On a TI, if you want to calculate something, you would hit second calc, and you can do value, which would be a YCal, and then you just type in an X value, and it will give you the answer. If you know a Y value and you want to find X, that's where you have to go into your TI and then type in another number, whatever it happens to be, and then graph it, and now find the intersection point. Casios, you can just do an XCal and then type in the number and it will find it for you. And when you find the intersection point, it's going to ask you the first curve and the second curve, and then it's going to ask you to guess, but you don't have to. And there you have it. It's 12.6 for 9. And that would conclude the review for the second half of your test.